Assalamualaikum and hello everyone. Topic 7, probability, subtopic 7.2, probability involving permutation and combination. The learning outcomes. Students should be able to distinguish between situations involve permutation and combinations. Find the number of ways to form combination of R objects from n different objects and determine the combination of a set of objects with condition. In our daily life, we always have situations between selections and arrangement of objects. Example, a boy wants to buy 3 different books from a bookshop. In the shop, there are 5 different books. Then, he selects 3 books out of 5. So, the selection of 3 books of 5 is a combination. If he arranged these books in his shelf in different ways, each way of the arrangement of books is called permutation. So, in which case the order of the books is important? It's permutation. Okay, for combination, a combination is a selection of one or more of set objects with no consideration given to the order of arrangement. For example, arrangement of 2 objects A and B are AB and BA. However, for combination, the order is not important. AB and BA are considered as one combination. Combination involves the task of choosing or selecting some object from a given group of objects. So the theorem is the number of combination of n different objects taken R at time is given by NCR. So please remember, for solve the combination problem, we can use C as combination. Example 33. There are 6 bottles of liquid dyes of different objects. Calculate the number of selections of the mixture of 2 different colors. Now we have 6 bottles and we want to select 2 different colors. So what is the answer, class? Okay, so the solution is 6C2, which is it have 15 ways to select of 2 different colors. Example 34. A bicycle shop owner has 12 types of mountain bicycle in the showroom. So it has 12 types of mountain. The owner wished to select 5 of them to display at a bicycle shop. How many different ways can a group of 5 are selected? So, is it permutation or combination? Okay. So, since the owner want to select 5 from 12 bicycles, so this is combination. So, the solution is 12C5. So the answer is 792 ways. Example 35. A quiz team of 4 is chosen from a group of 15 students. So, the number of students is n. We have n equal to 15. In how many ways could the team be chosen? So, the member of a team is 4. We want to choose 4. So, this is our so the formula for solve combination is NCR. Therefore, the answer will be 15C4. So, the answer is 1365 ways to choose a team of 4 members of a group. Next, example 36. How many ways for a student to answer any 6 questions from 10 multiple choice questions given in a test? Now, a student wants to answer 6 questions from 10 multiple choice questions. So, the n is equal to 10 and the student wants to answer 6 questions. So, the solution is 10 multiple choice question. Choose 6 answers. So, we have 210 ways. Combinations from multiple selection pools. When presented with multiple groups of items from which you are required to make a selection, you will multiply the case together. Example 37. A committee of 3 boys and 5 girls are to be formed from 10 boys and 11 girls. How many committees are possible? Now, we have boys and girls. So, from 10 boys, we want to form 3 boys. And from 11 girls, we want to choose only 5 girls. So, the committees are possible will be 10C3 and 10C3 for boys, and we can multiply the case together. So, we multiply by 11. From 11 girls, we choose only 5 girls. So, the number of ways is 55,442 ways to choose. Next example. For example 38. In a student must select 2 courses from group A, 2 courses from group B, and 1 course from group C. How many combinations are there? Okay, from group A, we have 4. Okay, n equal to 4. N equal to 4. Group B, we have 2. And group C, we have 3. Now, from group A, we must select 2 courses. So, from group A, we want to choose 2. So, R equal to 2 from group A. And 2 courses from group B. And 1 course from group C. So, by using the solution. Okay, how many we can choose? How many combinations are there? So there are 4C2 from group A multiplied by 2C2 from group B and 3C1 from group C. So we have 18 ways can we choose. Combination including specific items. To include or exclude particular items when making a combination will reduce the number of items in your selection pool and also the number of items you can select. Example 39. A school committee of 5 to be formed from 12 students. How many committees can be formed if Fikri must be on the committee? Now we have 12 students. So n equal to 12. And we choose 5 committee members. But the committees can be formed and the condition Fikri must be on the committee. So we have to choose Fikri first. So how many ways to choose Fikri? We only have one Fikri and we have to choose Fikri. So to choose Fikri, the number of ways is 1C1 and the balance student, we have 11 students, not include Fikri. So the balance is 11 students and we have to choose another 4 students. So 11C4. So the number of ways the committees can be formed is 21 ways. Example 40. In a test, a candidate is required to answer 8 out of 10 questions. Find the number of ways a candidate can answer the question if the first 3 questions must be answered. For the first 3 questions from 10 questions, you have to answer. So first 3 question is 3C3 and from 10 questions a candidate already answered the first 3 questions, so the balance of the question is 7 and the candidate must answer 8 from the 10 questions. Okay, the students already answered 3 questions. Therefore, the candidate must answer the 5 questions from 7 questions. Okay. So the answer will be 20. 21 ways. Okay, sorry, for example 39, it's not 21 ways, but it is 330 ways. Make correction for example 39. Okay, students, we proceed with example 41. Fifteen students are divided into 3 groups, with Group A having 7 students, Group B having 5 students, and Group C having 3 students. Find the number of ways to form the 3 groups. So the numbers we can choose to form the 3 groups is okay, so to choose group A, that is 7 students, from 15 students, we choose 7 students to form group A. And okay, we already choose 7 students. So the balance of the students is 8. Then to choose group B, we have to choose 5 students. Now we already chose 12 from the students. So the remaining students is 3. And we have to choose all the 3 students for the group C members. So how many ways to form the 3 groups? The number of ways is 360 ways. Next, for question B. The 3 groups with 2 given students must be in a group A. So, we have to form group A members first. For group A, the 2 given students must be in group A. So, choose the 2 of the students into group A, and for group A, we want 7 members in group A. So the remaining students, from 15 students, we already have 13 students. And to form 7 students, group A, okay, we want to choose 7 students. Then we already choose 2, so we want another 5 students to form group A. So this is for group A. Okay, next we can choose group B. So the remaining students is 8 students. For group B, we have to choose 5, and the remaining is 3. So the 3 students we have to choose for group C. So this is for group A. 5 students for group B from 8, and the balance is 3, and we have to choose 3 for group C. So what is the answer? It is 72,72 ways. Okay, class, we continue with combination with at least or at most. So we have to add the addition of all possible cases together. Example 43. A committee of 5 people is to be formed. So we have to choose 5 people from 4 men and 7 women. How many committees are possible if at least 3 women are on the committee? Sekurang-kurangnya, at least is sekurang-kurangnya 3 women. So, from 7 women, okay, women we have 7 women, and 4 men. Okay, then we have to choose at least. Okay, we want to choose 5 people, so R equal to 5 from N equal to 12, but we have to choose at least 3 women. So from 5 members, we can choose at least 3 women. So the woman, either 3 women or 4 women or 5 women, since the maximum people is 5. So the number of women not exceed 5 women. Okay, if we choose 3 women, so the remaining members is only 2 from 4 men. Then if we choose 4 women, so the balance we can choose 1 man. And if we choose 5 women, so 0 men we can choose, so no men. So what is the solution? So the committees are possible is, okay, from 7 women, we can choose 3, and from 4, we can choose 2, or from 7, we can choose 4 women, and from 4 men, we can choose 1 members, or 7C5 and 4C0. So all members, we choose woman. Okay, so what is the answer? The number of committees are possible is 371 ways. Is it clear? Okay, example 43. A school committee consists of 6 girls and 4 boys. A social subcommittee consists of 4 students is to be formed. In how many ways could the group be chosen if there are to be more girls than boys in a group? Okay, now we have 6 girls and 4 boys in a school committee. A social subcommittee consists of 4 students is to be formed. So we want to choose 4 students from the committee. In how many ways could the group can be chosen if there are to be more girls than boys? So the maximum members is equal to 4. So if we choose 2 girls and 2 boys, 2 girls and 2 boys, it will be equal number for girls and boys. So that is not more girls than boys. So we can choose 2 girls and 2 boys. So how many school committee with we can form? Okay, so from 6 girls, we can choose 3 girls or 4 girls. Since we chose 3 girls, so the remaining boys, only 1 boy we can choose. And if we choose 4 girls, so no boys, we can choose to form a committee. Okay, so what is the solutions? What's the solution? So from 6 girls, we choose 3, and from 4 we choose 1 boy. Or from 6 girls we choose 4 members, 4 girls, and no boys. 4C0. So the number of ways is 95. And the last example for this lecture, example 44. Read the question first. From a group of chess players which consists 4 male students and 3 female students, a school team which consists of 3 students to be formed. Calculate the number of ways the team can be formed if it must consist exactly 2 males. Now we have 4 male and 3 females. The question want to find the number of ways which the team is consists exactly 2 males. So if we choose 2 males, so since the team consists 3 students, so the remaining we have to choose is 1 female. So what is the answer? The answer is 4C2. 4 males, choose 2. And from 3 females, we choose only 1. So we have 18 ways. And the last one, the number of female must be more than the number of males. From 4 males and 3 females, the team consists 3 students, so R equal to 3, and the condition, the female must be more than the number of males. Okay, since we want to choose only 3 students, so we can choose 2 female from 3 or 3 females from 3. Okay, if we choose 2, so the remaining male is 1 male. And if we choose all 3 female, so no male we can choose. Okay, so from this table, we can conclude that from 4 males, we only can choose 1, and 3 female, we can choose 2, or either the second situation, we choose 0, no males, and all from female. Okay, so the answer is 13 ways. Okay, that's all for this lecture. Thank you.